everyone, this is Mrs. Snowbeck, and today we are going to cover Unit 1, Lesson 2. But before we start, I just wanted to do a little bit of review. This is not on your note sheet, so just kind of sit back and watch and try to remember how to do this stuff. If you have two fractions with a common denominator, can you add them? The answer is yes, you can add them, and so this would end up being 4/5. If they have a common denominator, you keep that denominator when you add. Are these two fractions ready to add? No, they are not. They need a common denominator. So you have to think about what number does 5 and 3 both go into. And 15 is a good number. So how do we get 15 on the bottom of each of these fractions? Well, for the first one, you would have to multiply by 3. Whatever you do to the bottom, you also do to the top. So you would end up with 9/15. On the second fraction, you would have to multiply by 5 to get a 15 on the bottom. So you also have to multiply by 5 on top. So that ends up being 10/15. Now you can add these fractions because they have a common denominator. So you wind up with 19/15, which you can leave at 19/15, or 15 goes into 19 once with a leftover of 4. So either one of these is technically a correct answer. Same thing here. I would get a common denominator. 8 is a good one because 8 and 2 both divide into it. So the first part, the 3 and 3/8, can stay the same. The second part is going to be 2, and we have to think, how do we get an 8 on the bottom? Well, we multiply by 4, so we also have to do that on the top. 1 times 4 is 4. Now what I do is I add kind of like terms. So the 3 plus the 2 is 5. And 3/8 plus 4/8 is 7/8. All right, one last quick fraction question. Again, even when you're subtracting two mixed numbers or fractions, you should get a common denominator. So again, 8 is a good common denominator because 4 and 8 both go into it. So if I want 11 and something over 8, I would have to multiply by 2 on the bottom. So I also multiply by 2 on the top. So that becomes 11 and 6/8. And the second part I can leave alone. So I have minus 4 and 5/8. Now when you're subtracting, it kind of works the same way. Take those coefficients out front. 11 minus 4 is 7. 6/8 minus 5/8 is 1/8. The second thing I want to quickly review, and this is going to be a big review from last year, you'll probably remember this, is solving linear equations. Again, this is something that in section 1.1 they expect that you remember, so I just want to take a minute and talk about it. When you have an equation and you're trying to solve it for a variable, first thing you want to do is simplify both sides of the equal sign, which in this case, part A, there's not much we can do. Second thing is get your variables on the same side of the equal sign. Again, that's already done. And then the third thing is you add or subtract the constant. So in this case, we want to move the 10. It's a positive 10, which is subtract 10. So whatever you do to one side of your equal sign, you're going to do to the other. You're going to wind up with 2x on the left and 40 on the right. And then the last thing, the fourth step, is you would divide or multiply by the coefficient. And so in this case, we have 2 times x. So the opposite of multiplying is dividing. We're going to divide by 2. And x equals 20. Will you take a minute and pause the video and try part B and then check your answer to see if you get it right? If you did it correctly, you should get A equals 4. Please pause the video one more time and see if you can remember how to do parts C and D. When you're done, then unpause. So for part C, you have -1 times B. So to undo that, you're going to divide by -1. When you divide a -10 by a -1, two negatives will make a positive. So you should get B equals 10. On part D, you want to move the 2 first. So you do the opposite. You have to minus the 2. Those will cancel out. Then you're going to have x over 3 equals 4 minus 2 is 2. And then to get rid of the 3, you're going to multiply by the reciprocal. So we're going to multiply by 3 or by 3 over 1. Whatever you do on one side, do on the other. These cancel out. We'll end up with x over 1, or x equals 6. we are finally at the point where we're going to start the actual note sheet. So at this point, go ahead and grab your note sheet. And here is Unit 1, Lesson 2. So we talked about points, lines, and planes. Today we're going to talk about segments. And a segment is basically part of a line that has two endpoints. So it's part of a line. And an example of what it might look like is this. So it has a definite starting point and ending point. It does not have arrows. It does not go on forever. And the way that you name it is you use the two capital letters that appear at the ends of the segment, and you put a bar above it, and the bar has no arrows. So will you pause the video, read the next two questions, and take a shot at them? When you're done, go ahead and unpause. Can you find the length of a line? Well, if you remember, lines go on forever and ever. So the answer is no. It goes on, or it goes in both directions forever. But can you find the length of a line segment? In this case, the answer is yes. I can measure it because it has a beginning and an end. It has a beginning and an end. So I could take out my tape measure or my ruler and I could measure the length of a segment. There are many types of rulers and tape measures, and so what you want to do is get your most accurate measurement. You want to measure to the nearest increment. In this case, part A, it's just counting by centimeters, you can see. So about the best we can do is we can say segment AB is, or the length from A to B is about 4 centimeters. Now notice there's nothing above this AB. That means the distance from A to B, or the length of A to B. The next one. Again, we're measuring in centimeters, but these centimeters have been broken up into millimeters. There are 10 millimeters in each centimeter. So think of, I kind of just draw this down. These, if you count, it's about 1, 2, 3, 4, 5, 6, 7. So it's 3 7/10, or I usually just say 3.7 centimeters. Now, when you're measuring in centimeters, it's a base 10. They're divided into 10 sections. So you can just take that number and use it as a decimal. 0.7 is the same as 7/10. This next one is a little trickier because you can see they want us to measure the length of segment RS, and this time we're measuring in inches. Now, inches are generally divided into 1/16. And so you can see from like the 1 to the 2, there are 16 little tick marks. And so when you measure, you have to measure to the nearest 1/16. So if I drop this down and kind of get a good look here, it looks to me like it's 1 inch, and then 1, 2, 3, 4, 5. So it's 1 5/16 inches. Now, can I write 1.5? I cannot, because it is not a base 10. It's 5 out of 16, which does not reduce to 0.5. Let's take a look at number 3. So let's start by finding the length of segment RS, and the top part of this ruler is again in centimeters that have been broken into millimeters. Take a look here. I would say that is possibly like 6 6/10. And so for centimeters, it's 6.6 centimeters, or 6 6/10. Down at the bottom, we're measuring in inches. However, you might notice these inches have been broken into eighths instead of 1/16. And so when we measure the length of segment TV, I'm going to notice it's a little more than 2 inches. So it's 2, and then it looks like it's 1, 2 more tick marks, but it's 2 out of 8 this time. So however many parts your measurements are divided into, that's the number that goes on the bottom of the fraction. Up here in part 2, we put 16 on the bottom because the inches were divided into 1/16. Down here on number 5, we're going to put an 8 on the bottom because the inches were divided into eighths. One last thing we need to do on number 5 is you always want to simplify a fraction if possible. In this case, 2/8 can be simplified. So 2 goes into 2 once and 2 goes into 8 4 times. So this is really 2 1/4 inches, and that would be your final answer. Notice I'm labeling my answers. That's really important because that indicates how long the units are. Number 4. Again, we're dividing inches into sections, and in this case, each inch has 1, 2, 3, 4 sections. So the number on the bottom of the fraction will be 4. So here we have a segment, CD, and the segment's measure is going to be 1 inch plus 1 more section. And so it's going to be 1 1/4 inches. At this point, please pause the video and see how much of this conversions chart you can fill in without Googling. So 1 yard is 3 feet, 1 foot is 12 inches, and one you might not have known, 1 mile is 5,280 feet. And yes, I want you to memorize that. 1 meter, it's almost as long as a yard. It's actually about 3 inches longer than a yard. A meter is a little bit bigger, but 1 meter is the same as 100 centimeters. 1 centimeter is the same as 10 millimeters, and 1 kilometer is the same as 1,000 meters. Next, we're going to talk about betweenness. Now, if a point is between two other points, it does not necessarily mean it's right exactly in the middle. It's just somewhere in between it. So you can see in this picture on the right that S is between R and T. And one of the things that I want you to notice is that if I add this distance from R to S to the distance from S to T, would it be the same as the distance from R to T? It would. The two small ones should add up to be the big one. So a couple of things I want you to write down. First of all, if S is between R and T, then segment RS plus segment ST, if I add those two small ones together, should equal the segment from R to T, or in other words, the big one. So here's a simple example. Find the length of segment XZ in the diagram below, given that XY is 4.5, or the distance from X to Y is 4.5 centimeters, and the distance from Y to Z is 3.2 centimeters. Well, if I'm supposed to find the length of the segment XZ from here to here, I'm just going to add those two numbers together. So 4.5 plus 3.2 is 7.7. If they have labels in their question, you should have labels in your answer. So 7.7 centimeters. Next, find XZ. Again, that's the distance from X to Z. Given that XY is 4 5/8 and YZ is 2 1/2. So to find the length from X to Z, we're going to have to add the two short parts together. So we're going to add 4 5/8 plus 2 1/2. This is why we practiced fractions. Are these numbers ready to add? No, we have to get a common denominator. So 8 and 2, a good common denominator might be 8. So I'm going to leave the first part the same, 4 5/8. And then I want 2 and something over 8. So what did I have to multiply the bottom 2 by? I had to multiply by 4 to get an 8 on the bottom. So I'm going to multiply by 4 on the top as well. So 1 times 4 is 4. Add your coefficients, the 4 and the 2, so that's 6. And then you have 5/8 plus 4/8, which is 9/8. All right, there's something wrong with this picture. Can you leave this improper fraction? Can you leave the 9/8 in this mixed number? Nope, you can't. So 8 goes into 9 once, and what you do is you bring that 1 out to the 6 and it becomes a 7. And then there's 1 left over. 8 goes into 9 once and there's 1 left over, so it's really 7 and 1/8. There is no label here, so then we're done. Number 8, find x and the distance from S to t if t is between S and u. Let's draw that first part. So it says t is between S and u. So what I would do is I would make a segment. Here's S, here's u, t is somewhere between them. And then label your stuff. The next part says S to t is 7x. So that's over here, 7x. S to u is 45. Well, that's that whole big thing down all the way across. So I'm going to write it like that. And then t to u is 5x minus 3. So that would be right here, 5x minus 3. Now remember the rule. The two small ones add up to the big one. So the two small ones are the 7x and the 5x minus 3. If I add those together, it should equal the whole long length, which is 45. Use your algebra now. So combine like terms on the same side of the equal sign. So we have 12x minus 3 equals 45. Then move that constant. Right now it's a minus 3, so we're going to add 3. Then we have 12x equals 48. It's 12 times x, so the opposite would be divide, and x equals 4. Now that's part of our answer. If you go back and read the question, it says find x and the distance from S to t. So to find the distance from S to t, what I'm going to have to do is I'm going to have to take x, or 4, and plug it in up here. So it's going to be 7 times 4, and 7 times 4 is 28. There are no labels in the question, so then our final answer, the distance from S to t, is just 28. Please try number 9 on your own, and then when you're done, go ahead and unpause and see if you got it right. So take a minute and check your drawing and see if your drawing looks like mine. Next, you set up your equation, and remember the two small parts add up to the big part. So the two small parts are the 3a and the 14. So you add them together and they should equal 5a minus 4. Now use your algebra skills. I'm going to move the a over to the other side. I'm going to get them on the same side of the equal sign, so I'm going to subtract 3a. Then I'm going to move this negative 4, so I'm going to add 4 to the other side, and then divide by 2. So a is 9, but that's not your final answer. It says find the value of a and xy, and so what we need to do is we need to take that 9 and we need to plug it in right here. So to get the distance from x to y, it's 3 times 9, which is 27, and there's no label, so 27 is your final answer. Finally, I want to talk about the word congruent. Congruent is basically another way of saying two things are equal. Congruent means same size, same shape. So numbers can be equal, but shapes are congruent to each other. So in this case, I notice MN, segment MN is 2.1 centimeters, and segment QP is also 2.1 centimeters. So I could say something like this. Segment MN is congruent to segment QP. Now notice that symbol right here. It's an equal sign with a squiggle above it. That means congruent, or is congruent to. So down here in this box, I'm just going to make it a little bigger. It's an equal sign with a squiggle above it. That means congruent. So going back to the top here, segment MN is congruent to segment QP because segment MN and QP have the same, you could say length, or you could say measure. Either way, both words work. One more indicator of congruent segments, and this part is not on your note sheet, but I wanted to show it to you, is the number of tick marks on a segment. So you can see if two segments have the same number of tick marks, they are congruent. For instance, segment EF would be congruent to segment HG because they both have one tick mark. Segment AB would be congruent to segment CD because they both have double tick marks. So watch for that. That gives away some information as well. That wraps up Unit 1, Lesson 2, you guys. So now I want you to try the practice. If you get stuck, send me a message and just let me know what you're stuck on. And then drop it to me in Schoology when you are finished. Don't forget you need your syllabus signed. If you're taking notes on paper, get some kind of a 3-ring binder or a folder. And remember, you need to be working on getting that calculator. The TI-30 is going to be good enough for this year, or the TI-84 Plus if you want to get the graphing calculator. Thanks a lot, you guys. Bye.